Claire Elementary, and we are here to embark on another math lesson. I really love this one. There's so many different things we're learning in 5th grade and below, but one of the cool things that we're going to learn is about prime and composite numbers. I'm going to say that again. Prime and composite numbers. So just as always, make sure you have something to write with because you're going to be following me along as I teach you about prime and composite numbers. So today I'm going to be explaining a lot of vocabulary. It's going to be familiar to you, hopefully. Some remember things and different things we're going to do with it. We're going to talk about math vocabulary. That's going to help set you up. We're going to focus on some important math facts that will help us determine whether a number can be classified as prime or composite. So let's start with this. Have you ever even heard of the word prime and composite? So I don't mean Amazon Prime, right? A lot of people are like, oh, like Amazon Prime, but not really, right? There's some really cool mathematical things that we discover as we carry on through our math education. One of those things is whether a number is classified a certain way. And the first thing I want to start out with is talking about why do we even have them? So as our focus today, prime and composite numbers. So you can kind of watch that the entire time we're there. But the main thing I want to do is I want to start out with this bright yellow arrow that tells us, like, why do we even have that? So I like to think about it as like, well, okay, but how are we going to use this in real life? Let me tell you. Okay, so read with me. I'm going to show you how to find them, but first I'm going to tell you why they exist and who uses them. So think about it in the context of the world, right? So we actually use the mathematical classification of numbers in animal and insect life cycles. How cool is that? So basically, scientists have studied animal life cycles, and they've noticed that certain predator insects, I should say, come out from underneath the ground in intervals of prime years. And that's how they figured out that certain insect species don't become extinct. They have found a pattern with numbers that helps us understand how animals go extinct. Isn't that interesting? There's so many things you can look up about it. Also, in engineering, which is a great profession if you one day decide to do that, they have like gas turbines and all kind of machinery that relies on the knowledge of certain numbers and how they're classified, specifically prime numbers, that helps them with the rotation of turbines. Look it up. It's super cool. I just kind of wanted to give you an overview. And online security. What do I mean by that? So as you know, we shop online, or your parents do. We bank online. Everything is coded by numbers inside of our internet system, right? So even those of you who, I know you buy things on the internet, like for your games and things like that, there are certain codes, computer codes, that are put in using prime numbers to avoid theft. So that's just 3 things right there. So I'm going to hold that up for you. Kind of cool. I'm going to put that here because that is why we have them. They help us in real life. So now that we've gotten that out of the way, let's talk about how to figure out what numbers are prime and composite so we can start looking for those patterns. Okay, so I'm going to review with you some important things, very important things. Before now, factors. 2 numbers multiplied together. A factor times a factor is a product. So I'm going to put that here. A factor. Let's do one together. Any factor, any number multiplied by another number is a factor. Okay, anyone. I did 3 times 2 here, but you could do like what? Give me one. 8 times 3. 8 times 3. Those are factors, and this is the product. Remember earlier in the video, I said that I was going to review some math vocabulary with you? That's what I'm talking about. So hopefully you already know this. Factors are 2 numbers multiplied together. Their product is the answer. Got it. This is important. Next. Do you like how I'm doing bright colors? I think it helps. You have, hopefully, it looks like I'm yelling this, right? You have hopefully used arrays, and those are where we take the length and the width of something and it tells us the amount of squares, okay? So in this case, we have a 1 by 5, and you can see I have 5 green squares. Here in this array, we have 3 rows and 4 columns. So if you multiply 3 times 4, also known as the factors, you would get 12, which matches the 12 squares. Okay, those are arrays. This is review. Okay, arrays you have used. They are used to calculate area, the amount of space something that takes up. Okay, and another neon one, factor pair. Again, just like with all my videos, I'm holding up a lot of notes. Your job is to hit that pause button if you need a moment to write it down or need to rewind it. You can do all of that. This is why I record these for you, okay? Let's talk about factor pairs. I'll come a little bit closer. A factor pair is a set of 2 factors. Remember what we just said about a factor? It's a number that's being multiplied by another. So look at my sheet. 2 factors means 2 factors, right? And that would be called a pair. And I always tell students, think of it as a pair of shoes. I don't know anyone who has a pair of shoes that's more than 2, right? One for one foot, one for the other. Unless you have 3 or 4 legs, your shoes come in pairs, right? So factor pair is 1 multiplied by another. So let's look at 12. 12 has 1 times 12. That's 1 factor pair, a pair of shoes. 2 times 6 also equals 12, another pair of shoes. 3 times 4 also makes 12, another pair of shoes. So I wrote them out here, 1, comma 12, because 1 times 12, 2, comma 6, because 2 times 6, 3, comma 4, because 3 times 4. Let's look at the conclusion. 12 has 3 factor pairs. It has 6 factors, but 3 pairs. Think about that. So all of this here is our review of certain vocabulary that we're going to be using today as we look for prime and composite numbers. So once again, if you need to take a moment and pause this video so you can review all this, that is completely fine. I'm here to just help you use this vocabulary in our next lesson as we move on. So you guys are doing an awesome job. Pause if you need to. I'm going to go ahead and move on to prime and composite notes. So I'm going to go ahead and open this. I'll leave this here in case you still need to refer to it as I teach, okay? But in a moment, I'm going to have to cover that up as we get into our examples. Okay, so the next thing I'm going to open up here is notes about prime and composite numbers. So let me open that. We're going to start with a prime number. How do you know if a number is prime? Well, let's figure out what that is. So I always like to start out with just a little bit at a time, right? So that way you're not trying to learn both at once. So let's first talk about prime numbers, okay? And I put this big, huge 5 here because we're going to talk about the 5 as an example. So you're going to write this down. Prime numbers, okay? Right here, prime numbers. So let's give that a try. A prime number, write this down, has only 2 factors, 1 and itself. That is the only way you can get to that number is by multiplying the number 1 and the number 1 in itself. And it's going to make a lot more sense when we try it, okay? So just write this down for 1. That is the rule. So take a minute to write that down. Pause if you need to. Also, since we talked about that array, if a prime number only has 2 factors, 1 in itself, there's only going to be an array of 1 times that number. It will have 1 rectangular array. So in our case, we're using the number 5. Look right here. This is our example. We're using the number 5. So I drew an array. Remember the array? The graphical representation of the number with the length and the width. So I drew 1 row times 5 columns. And the yellow pieces are 1, 2, 3, 4, 5. And that is 1 times itself. There is no other way to get 5. using whole numbers. You must only use whole numbers, okay? There's no other way to get 5. Just 1 times 5 or 5 times 1, right? But those are the same factors, so it didn't add any extra factors. On the other hand, the other item we have are composite numbers, okay? Composite numbers have more than 2 factors. So we're going to use 6 as an example this time. So I want you to take a look at this and I want you to write down this definition. A composite number has more than 2 factors. Okay, so write that down for real quick. Okay, so hopefully you got that written down. A composite number has more than 2 factors. So in this case, we're going to use the number 6. So up here we used 5, and here we're going to use 6. So let's check it out. How can we get 6? 1 times 6, which is 1 times 6. We can also get to 6 with 2 other factors. 2 times 3, right? That's the other one. So there's another way. So now we have more than one rectangular array. We have 2 times 3 equals 6. Okay, we're about to practice a lot of this. Okay, I'm gonna move these notes over here because here we're gonna do some examples, and I promise this is gonna get easy. Right now you're just learning the definition, so you might not be able to connect it quickly if you haven't practiced it. So let me move this. Here, if you're still writing those notes, no problem. Now, I put this note up here and it says factor tree because we are going to use something called a factor tree to figure out if our numbers are prime and composite. It's really fun. So you got to be strong with your math facts. So always continue to learn your math facts so that you can continue to progress in your math career. So that is very important. So let's give it a try. All right, so a factor tree it's called a tree because it kind of looks like one when you work on it. So I'm going to get a green marker so we can think of a tree, right? A tree kind of looks like this, right? Okay, and then we have a little stem, right? I always tell my students, I'm not an artist, I'm a math teacher, but sometimes I can draw pretty good. I don't know about this though. All right, so my point is, the reason it's a factor tree is that it goes down like this, and we're about to explore that. So let's try the number 8. Let's work on 8 together. So we're gonna put an 8 just like that. So you're gonna write that in your notes, an 8. And now we're gonna draw sort of like arms coming out of it showing all the different factors. And remember, let's go back. A factor are 2 numbers being multiplied. It's on that green one. 2 numbers being multiplied. So I'm gonna find all the numbers, all the factors. I wanna use big words, right? Big math words. I wanna find all the factors that help us reach 8. So let's work together. Our factor tree, here we go. So you're gonna kind of draw like pretend branches. So I know that to get to 8 is 1 times 8. You always start out finding the factors of a number. 1 times itself is gonna be first, and that's easy. 1 times the number. And there are other ways to get to 8. What are the other ways? 2 times 4, you got it. 2 times 4. There we go. And if you remember, a prime number has only 2 factors. 1 times itself. A composite number has more than 2 factors. So anytime you reach that second level, anytime there's something in addition to 1 times itself, it's automatically composite. And I just put a C because that stands for composite. So back to our example. Anytime I find out that it's composite, just label it C. And when we find out that it's going to be prime, we'll just label it P. It's real easy. All right, let's try another example. Okay, so that was 8. Let's try 10. So I'm going to draw my factor tree, and I'm going to think of all the factors that make up 10, okay? What did I say earlier? We always start with 1 times itself being the number. So 1 times 10, that was easy. How else, what other 2 factors, remember numbers that multiply together, what other factors can we think of for 10? 2 times 5, you're right. 2 times 5. Anything else? I think that's it, right? Now, some of you might be asking, well, what about the other way around? What about 10 times 1 and 5 times 2? Yeah, those are also factors, but there's no difference because you already have the 5 here. So there's no need to do it the other way with the fact family because it's the same factor. So just because it multiplied together, so you really don't need to duplicate those. So since we have more than 2 factors, we have 1, 2, 3, 4 factors, we can say that this one is also composite, okay? We're gonna keep working on them. Okay, let's try 7. How do you get 7? 1 times itself. 1 times itself. So 1 times 7. You always start with 1 times itself. Is there anything else that's a whole number, 2 factors, that can get a 7? Nope, nothing else there, right? The only other way we could get to 7 is if we use the decimal, but we cannot use decimals when talking about prime and composite numbers. It's for whole numbers only. So look up here. A prime number only has 2 factors. 2 factors, 1 and itself. 1 and itself. So you're right. This is definitely a prime number, and I'll put a P. P for prime, C for composite, okay? It's that easy, y'all. It's literally that easy. Let's practice some more. Hopefully, you're finding a place in your notebook where you're keeping track of all these, okay? So these numbers can get kind of unique. Any number can be tested, and it gets real fun. And like I said, this does have a real world application. So let's try 15. 15. 1 times itself. That's always the easiest one, right? 1 times itself. What are some other ways we can get 15? 2 times something? Nope, doesn't go evenly. 3 times something? 3 times 5, right? You got to know your math facts. 3 times 5. Anything else? Any other way to get 15? I think that's everything, right? But the fact that as soon as you have a second factor pair, because remember, this is a pair, this is a pair, and this is a pair. Anytime you have 2 pairs, that means you already have 4 factors. Immediately after you're able to find another factor pair, you immediately have composite. It's that easy. C. If we were to look at this with arrays, we would draw those. You can draw this if you want to. Remember the arrays. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I need more. That's going to be 12, 13, 14, 15. Oh, that's a long one. So I have, let me use a different color. That's an array. Don't worry about the numbers. There are 15 in there. So this would be 1 times 15. 1 times 15 equals 15. Now my second array would be a 3 by 5. So I would have, oopsie, you'd be surprised how often that happens to teachers dropping pencils. So for this one, I would have a 3 by 5. This is an array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3 times 5 is 15. So this one I kind of took you on the long route and I showed you that the factor pairs match the rectangular arrays, these arrays. So if you have more than one array, you have more than one factor pair, which means this is composite, okay? So let's look at another number. How about a number like 11? How do I get 11? 1 times itself. Is there any other way to get 11 using whole numbers? Nope. So just 1 times itself makes this prime. Okay, what about 27? 1 times 27. How about 3 times 9? Anything else? So you guys are probably thinking, look, she found another factor pair. As soon as you have that second one, you're going to be ready to call this a composite, okay? What about a number like 33? This one is always tricky for people because this number is odd and doesn't look like it has a lot of factors. People assume incorrectly that it's a prime number, but it's not. You're going to have to get really creative with your math facts, okay? You're going to have to really dig deep and think, how is this? How can I represent this number with different factors? So, as always, start with your regular 1 times 33. That's the easy one. Now, I'm going to look at 33 and I'm going to think about this for a second. I know I can't have a multiple of 2 because it's not an even number. So how about 3? Can I multiply 3 times something to get to 33? And this is where you really have to get that practice in on your math facts because the answer to that is yes, right? We can. 3 times 11, if you remember, is 33. So once again, as soon as we have that second factor pair, the minute we have something more than just one in itself, it's composite. And another way that a lot of my students remember this is that the word prime is shorter than the word composite. Look. So the word prime is a shorter word than the word composite. See, it's a shorter word. And prime has less factors than composite prime numbers. So that's another way to remember it. But honestly, the more you practice, you're gonna get really good at prime and composite numbers. You're gonna be able to look at a number, find your factor tree, and you're gonna be able to do it, okay? I'm actually gonna do one more thing before I head out, and I'm gonna do a tougher example. So we're gonna walk through a practice problem that is a little bit tougher. So it's gonna take us a little bit more time. So that's the last thing. So grab a new sheet of paper or turn your page so that you can follow along. Okay, I want you to look at this. This is our problem, okay? This is written in a Word format, and we're gonna try to figure that out together. I'm gonna need some more paper, so you guys write that down. so hopefully you had a chance to look and write this down. Again, always pause. It's not a big deal. That's why this is recorded, okay? So I got about 5 minutes to get through this, but you're gonna be really good at this. It just takes practice. So let's read this together. 5 students each wrote down a number between 70 and 80. So there's 5 people, 5 students, and they each wrote down a number between 70 and 80. And our question is asking us, always focus on the question, which student wrote down a composite number? So what are we looking for? Easy. We're looking for which one of those numbers is composite, right? So are we going to guess? Nope. Obviously not. We are going to test using a factor tree, just like we've been doing this whole lesson. We're going to test all of those. And the minute we find a second factor pair, we're going to know it's composite. If we can't find another factor pair in addition to 1 times itself, it's going to be prime. We don't care because we're looking for the composite. But just as with any other math question, always test all of them. You must look through all of them. So let's just get started, okay? So Mimi wrote down the number 75. So I'm going to start with that, 75. And I'm going to write 1 times itself. Did y'all see what I just did there? 1 times itself, okay? Then I'm going to look at 75 and think, that's a big number. I really don't know, but I have some clues. Any number that ends in a 5 is divisible by 5. So I know 5 times something will be 75. But if you don't know in your head, just come over here and do some division. 75 divided by 5. I'm looking for the other factor that makes up 5 times something is 75. And my clue tells me that if it ends in a 5, it's divisible by 5. So I'm going to divide it. 1 times 5, 25, and I will get 15. So 5 times 15 equals 75. Also, use your knowledge of money. I know 75 cents is 3 quarters, and I know that a quarter is 25 cents. So 3 times 25 is also. But here's the cool thing, y'all. You didn't even have to go this far. As soon as you found a second pair, you can label this composite. So I'm going to put a C right here next to Mimi because they were asking me for the composite number. So that might be it, but I should still test the other ones, right? So let's look at Greg's number. Greg wrote down, let me put this here so you can see. Greg wrote down 7, so we're right here. We're going to test 73. 73. 1 times itself. I know that that's 1 times itself. That's going to be every time. Now, I know I can't use 2 because this is a odd number. Can I use 3? Let me try. 73 divided by 3. 3 into 7 goes 2 times, and then I have 13 left. And then I can't do this without a denominator, so that's not going to help. Can I do 4? No, it's not odd. I can't do 5. What about 6? Let's try 6. 73 divided by 6. I will get a remainder again. You cannot have a remainder. So I'm pretty sure that 73 is prime because there's no other number but 1 times itself. So we're going to say that 73 is prime. Okay, what about Katie? She had 78. So we know 1 times itself. And I already know this is going to be composite. Hopefully you guys do too because it's divisible by 2. And how do I know that, right? I know that because it's an even number. So 78 divided by 2 gives me, ooh, that's not right. That happens sometimes. Let's try that again. 78 divided by 2. 2 times 3, Miss Smith, equals 39. So 2 times 39. And I could keep testing other numbers, but I don't need to because as soon as I find that second one, bam, composite. So here's another composite number. Okay, 2 more to test. 77. You can see my factor tree down here. 77 for Allie. Let's try Allie. All right, here I go. 77. Right here. So I have 1 times itself. And remember what I said about those double-digit numbers. 11 is a factor. 7 times 11. So 77 is also composite. Cool. All right, last but not least, I'm going to use the bottom of this sheet of paper to do our last one. The last test. We've tried Mimi, Greg, Katie, Allie, and now I'm trying Nicole. So far, I only have 1 prime number. So Nicole's number was 79. So as usual, 1 times itself, and these are the bigger numbers, right? So what about 2? I definitely cannot use 2 because, very good, it's not even. What about 3? 79 divided by 3. 3 goes into 7 2 times, and I get 19. 19 cannot be divisible by 3 because I will have a remainder, so I can't use 3. Can't use 4 because it's odd. Can't use 5 because it doesn't end in a 0 or 5. What about 6? 79 divided by 6. I would get 19, which is also a number that would give me a remainder. Pretty sure 79 is prime. So, back to our question. Which student wrote down a composite number? So notice I labeled all of them, which is a great habit to get into, right? So Mimi, Katie, and Allie, all 3 of these students wrote down a composite number. So if this were a question, you would have 3 different students who wrote down a composite number. I really hope you can see the importance of labeling C and P on every number, on every choice. It will help you answer questions correctly. Okay, I really hope you guys had a great lesson. Please rewind, please pause, do what you need to do to review it. There's a lot of vocabulary here, but I hope you'll find that finding prime and composite numbers is actually really easy if you just use your factor trees, right? You can use arrays to help you. You can use all kinds of different tools. I know you can do it, and I encourage you and challenge you to look online of all the amazing things that scientists and engineers and other professors and professions have used with the knowledge of prime and composite numbers. There's really unique things that we can study about the world. So I hope you had a great time. See you next time.